Welcome to qnawire.
This problem asks us to find the energy contained per 1 mole of photons with the following wavelengths. So for letter A, we have 0.150 nanometers, and we can convert that to meters by there's 1 meter for every 10 to the 9th nanometers. So we can convert that into 1.5 times 10 to the minus 10th meters. Now we can find the energy of a single photon by E equals hc over lambda, the wavelength. H is Planck's constant, 6.626 times 10 to the minus 34th. C is the speed of light, so that's 2.99 times 10 to the 8th. And we divide that by our wavelength we just found of 1.5 times 10 to the minus 10th. And that gives us our energy per photon to be 1.326 times 10 to the minus 15th. So that's joules per photon. But we don't want joules per photon, we want joules per mole. So to get joules per mole, we just multiply by Avogadro's number, 6.022 times 10 to the 23rd. And that will give us our final answer of 7.98 times 10 to the 8th, and that's joules per mole, which is what we want. Now we do the same thing for letter B. We start with 2.15 times 10 to the minus 5th nanometers, and we convert that the same way, so 1 meter over 10 to the 9th nanometers. Now nanometers cancel, and we get our wavelength in meters, 2.15 times 10 to the minus 14th meters. And we use that same formula, E equals hc over lambda, the wavelength, to determine the energy of a single photon. So 6.626 times 10 to the minus 34th times the speed of light, 2.99 times 10 to the 8th. And we divide that by our wavelength, 2.15 times 10 to the minus 14th. And that gives us our energy per photon to be 9.22 times 10 to the minus 12th joules per photon. So again, we multiply that by Avogadro's number, 6.022 times 10 to the 23rd. And we get our final answer to be 5.55 times 10 to the 12th joules per mole. And that is our final answer.